Differential testing is the preferred way of testing dresser roots meters to determine their performance. More than 50 years of practice have proven differential testing as an effective, efficient, and easy performance evaluation method. Differential testing has a long history of use. This method has been tested and approved by the United States National Bureau of Standards, several state governments, and the Canadian government. After viewing this video, you'll be able to describe why differential testing is an appropriate way to determine meter performance. You'll also be able to outline the procedures for differential testing of Roots rotary meters. Roots rotary meters maintain a constant volumetric accuracy. Two counter-rotating lobed impellers trap and pass fixed volumes of gas through the meter from the inlet to the outlet. The clearances between the rotating impellers and the meter casing effectively isolate gas at the inlet from gas at the outlet to prevent any unmeasured passage of gas through the meter. The only gas that passes through is the fixed volume swept through by the impellers. Because the trapped volume is fixed by the dimensions of the meter housing and the impellers, volumetric accuracy of the Roots meter is permanent and non-adjustable. In addition, the National Bureau of Standards has shown that the static displacement of a rotary gas meter appears to be almost unaffected by deposits. This means that the volumetric accuracy of the meter does not need testing. There are 4 factors which can affect differential meter pressures and therefore meter accuracy. The first factor is flow rate, which can be measured and controlled. The second is the specific gravity of the substance flowing through the meter. For example, air and natural gas have different specific gravities. So for future reference, you need to know on which you are recording your test data. Third, the actual pressure itself, which can also be measured and sometimes controlled. The final factor is internal resistance, friction. Because the other 3 factors can be controlled or measured often and are often constant, any pressure change must be attributable to internal resistance, and a higher pressure drop will cause the meter to read inaccurately at the lower flow rates. In a properly operating meter, internal resistance is negligible. A pressure drop of less than 0.05 inches of water column is sufficient to rotate the impellers of a meter of this size. However, internal resistance can increase the pressure required to turn the impellers, which causes the volume of gas metered to be underestimated. Internal resistance can be detected by measuring the pressure drop across the meter. Differential testing measures the pressure drop to indicate the extent of internal resistance by comparing upstream and downstream pressures. Any internal resistance will increase the pressure drop across the meter. Because the pressure differential will be very small, manometer or differential pressure gauge with an appropriate scale for reading small changes is used. The manometer is used to measure the pressure loss through a meter. The manometer scale should measure 1/10 of an inch of water or smaller, and it must have a range of several inches for high pressure testing. Caution: do not exceed the allowable working pressure of the manometer. An initial differential test should be performed on a meter under actual operating conditions when it is installed. These test results confirm proper installation and operation and form a basis for comparison with later tests. Differential testing should also be performed periodically, every 3 to 10 years, or whenever the accuracy of the meter has come into question. Here's how you perform a differential test. The first step is zeroing the manometer. Open the high and low pressure valves on the manometer. Next, adjust the level with the adjusting knob until the top of the curve of the fluid is level with the 0 mark. To attach the manometer to the meter, make sure the high and low pressure valves on the meter are closed. If a gauge is connected to the high pressure valve, disconnect it at this time. Take off the caps. Then, open the manometer's bypass valve. Connect the high pressure connection on the manometer to the meter inlet tap. and then the low pressure connection on the manometer to the discharge tap on the meter. Some meters have permanently installed taps, which make this job easier. If the manometer connections have valves, open them at this point. Now open the high and low pressure valves on the meter inlet and discharge connections. Open them slowly and simultaneously. Close the gauge bypass valve to apply differential pressures to the manometer. Remember that any leakage in the differential test equipment will result in test errors. Now read the differential from the manometer and write it down. The size of the pressure drop depends on the flow rate. As flow rate increases, the differential pressure increases. To show the different values, we use a graph like this. The bottom scale indicates the flow rate as a percent of maximum flow. The top scale indicates inlet flow rate in actual cubic feet, and the left scale indicates differential in inches of water column gauge pressure. At this point, you also need to calculate the flow rate of the meter. With a stopwatch readable to 1/10 of a second, time the flow volume. Now take the sample size and multiply by 3600. Then divide the result by the time in seconds to determine the flow rate. Differential testing is usually done at operating flow rates. If possible, an initial test should consist of 3 readings, taken at different flow rates, usually 25% flow, 60% flow, and 80 to 100% flow. 3 points allow you to plot a specific graph of flow rate and differential pressure for your meter. A follow-up test will require only 1 differential pressure test at an existing flow rate, assuming the flow is between the initial test minimum and maximum flow rate. To vary the flow rate, partially open the meter loop gas bypass valve to reduce flow rate through the meter. Again, use the stopwatch to calculate the flow rate. Make any additional adjustment to the meter loop bypass valve and recalculate the flow rate until desired flow rate is reached. Then measure differential pressure as before. Once you have completed taking all your differential measurements, you may plot them on the graph. Plot the 3 measurement points taken from your differential tests. Now draw a curve through those points. Operating test results will vary some from lab testing results. If original tests are not available, Dresser can provide standard meter characteristic curves which you can use for comparison on follow-up tests. According to the National Bureau of Standards, a 50% variance from original measurement is allowable. The meter's accuracy will be maintained. If you are using Dresser standard characteristic curves for comparison, the variance limit is 30%. Once you have completed taking your measurements and plotting them on the graph, you can remove the manometer. First, open the manometer's bypass valve. Close any inlet and discharge valves that are open on the meter. Next, remove the high and low pressure hoses from the meter and bleed the pressure off slowly. Then, close the gauge valves. Replace any caps on the meter taps or valves. If your readings disclosed an unacceptable pressure differential, it's highly likely that the pressure drop is a result of internal resistance, as explained earlier. Internal resistance is usually caused by binding impellers, dirt, worn bearings, heavy lubricating oil, or too much oil in sumps. Because the equipment is carefully manufactured, The most common problem is dirt or grease on the impellers and cylinder surfaces in the metering chambers, or the use of incorrect or excessive lubricating oil. In a large majority of cases, flushing or re-lubricating the meter can reduce the internal resistance to an acceptable level. Here is the recommended procedure for flushing a meter chamber. First, drain the oil from the meter and remove the meter from the line. While rotating the impellers manually or using compressed air, the impellers should be flushed with non-toxic, non-flammable solvent, and then dried with air or a clean rag. And then replace the oil. Once the meter is cleaned, the meter can be reinstalled and the differential test can be rerun to verify that the pressure drop has returned to the acceptable range. Dresser has collected information on differential testing from many state utility commissions and gas utilities and will be most happy to provide it to your company upon request. Differential testing is an important and effective tool you can use to ensure that your Roots meters are performing accurately. Take the time to perfect your differential testing knowledge and skills. It will be time well spent.